Hello, everyone. Uh, Welcome to my YouTube channel again. I would like you to like and subscribe and follow is important. Okay, today we are going to be looking at a popular mathematics topic titled differentiation. And we are going to, I've actually done a video on this in different categories, but I decided to animate it so you will understand it better. So the introduction part of it is that we are going to be looking at differentiation, how to solve it, how to apply it to solve question, and basically, we are going to do more of the basic aspects of differentiation. Now, quickly, we know that differentiation is actually used to find the gradient of a curve at a point. You know, when you want to find the gradient of anything, when you want to find the gradient, it's change in y over change in x. So that is why of a straight line, want to find the gradient of a straight line is change in y over change in x. So differentiation is used to find the gradient of a curve. Now, you know the curve keep changing. It's not straight like straight line. So you can only find the gradient of a particular point. That is why you use the y over the x to find it, like changing y over changing x of that particular point. So on a straight line, like I just explained earlier, that is one thing about differentiation. So differentiation is actually very easy. So when I was a little boy, when they carry calculus, I feels that, oh, this is the hardest part of math. But it's just a little quick principle. Is that this is a typical function of how a equation will be. Is a function of ax raised to power n. Now, when you differentiate it, all you need to do is multiply the power with the function and subtract not 1 from the power. That's all. It's as easy as ABC. That is, if you have something like this, 2x squared, all you need to do, you multiply the 2 with the function, which is 2x, it will give you 4x. You subtract 1 from the 2, it will give you 1, which you will have 4x. So that is actually very easy in solving a typical differentiation. What do you just do in finding differentiation when they use the y over the x? Yeah, all you need to do is the power, use it to multiply the function, a particular function, then you subtract 1 from it. That's all. It's as simple as that. Now let's look at this example. We say find the function of find the derived function of each of the following. That is, when you use the derived function, they're also asking you find differentiate it. If you use the word dy over the x when they are differentiating the y over the x, or you can use the function prime. They are just the symbol for differentiation. Just like I told you, this particular one, all you need to do, multiply it by 3, because the power is 3, then you subtract 1 from the 3 and get the answer. Very easy. Now try this one. The function is 2x squared. And just like what I did, you multiply it by 2, you multiply it by 2 and subtract and subtract 1 from the power, and your answer will be 4x. They are very easy. Look at this one. The power is negative 2. So the same procedure is applied. You minus it, you multiply by -2, and -1 from -2, you give you -3. Do you see how simple differentiation is? This is just the basic rule of differentiation. Look at this one. Find the derived function of each of the following. F of x is equal to 1 over x squared. It's still the same thing. Using that y indices is important. If you see a problem with indices, I would like you to watch some of the videos I've posted earlier on indices. 1 over x raised to power 2 is the same thing as x raised to power -2. And if s is raised to power -2, you can go ahead and do the needful. What do? You subtract 1 from -2, you give you -2. You multiply it by also, you give you -3, and you multiply that -2 with the function it will give you minus 2x raised to power minus 3. Simple. Now, f of x is equals to square root of x. We all know from the indices that square root of x is the same thing as x raised to power half. And that half still do the same thing. X raised to power half, you still do the same thing. Then you multiply it and you get your answer. Very easy to do. Very easy to do. Now, let's move on to some of the exercise that we are going to do. Understanding this principle will help you. Remember, I told you that differentiation is used to find the gradient of a curve at a particular point. Now, you are given this one, they ask you, calculate the gradient of this curve. You are given the curve to be x squared. So there are only two steps that you do there. You find the gradient of the function. Then at the point where x is 3, you put x there, 3, and you get the gradient. So easy. Then if x is 3, then you put it there, 2 times 3, you give it 6. Look at the second example. Calculate the gradient of the curve, f of x at the point, at the coordinate x. Remember, we are looking at the gradient where x is a particular point. So the same thing that you do, you differentiate, then you put the value of what x is, and you get your answer. They can do it anyway. They can give exactly the x value, or they can give you the points, the coordinates, and you're expected to just use the x value to solve it. Look at this one. Remember, it can be, when they said find the y over the x, that's it saying the same thing about differentiation. So the algebraic part of the differentiation, this is what we are actually looking for. They say find the differentiation. Now there are more than one of the thing here. So you are going to work at it one after the other. So you do the one of x squared, you do the one of minus 6x. So that will actually help you to get what you do. Now, it's important to know that when you differentiate a constant, it will give you 0. Anytime you differentiate a constant to give you 0, that means if I differentiate that -4, I'm going to get 0. Okay? So the y over the x will now be, as usual, when you differentiate x squared, it's going to give you 2x. And when you differentiate 6x, you're going to give you 6. How do I know? I'm minusing 1 from the power of x, which will give me 0. And anything raised to power 0 from our law of indices is 1. So 1 times -6, you still give me the same thing. You see, also means the gradient of a function. Now, they can ask you also, find the y dx when y equals to this. They're asking you the derivative also. The same thing I told you. When you differentiate a constant, it's going to give you 0. So you're only focused on -5x squared, which is what we just did here. Another one again that we're looking at here, it said, let f of x be 4x squared minus 8x plus 3. Find the gradient of the curve. Okay, y is equal to f of x at the point of, they are just using grammar to confuse you. Once you understand the principle of finding the gradient is that you differentiate the function and find the x value, put it in the equation, and you get it. This is it. The 3 there is going to be 0. Like I said, you only differentiate 4x squared and -8x. Okay, simple. When you differentiate, you give this, then you put the value of x, which is half, and you get your gradient. Is that not simple? Now, look at another example. We say find the coordinates when the graph y equals to 2x squared minus 5x plus 3 has a gradient of 7. This one is a little bit tricky. This time around, they have solved the equation for you. They want you to find the coordinate of the x. So you see the same thing you are going to do. This time around, all you need to do is to differentiate it. And when you differentiate it, the answer you get, you equate it to 7. Then you find your x. In other words, they're asking you, what is your x? So 4x minus 5 is equals to 7. Then from there, you can just do your basic algebraic simplification, and you get what your x is. That means if you differentiate it at the point where x is 3, you are going to get a gradient to be 7. You see, as simple as A, B, C. Is that not beautiful? Now, they're asking you to find the coordinate. Now, the two things you need to understand is that now that you have found what your x value is, for you to find what your x value is, for you to find what your y value is, you go back to your main, function, apply the x there and get your y. Please don't make mistake of putting your x in the differentiated one. No, put it in the original equation. Okay, good. So one more example, very simple. I love differentiation. Find the gradient of the curve when y is equal to x squared. Okay, where it meets the line y is equal to 4x minus 3. Now it becomes a little bit tricky also. Now they're asking you to find the gradient of this curve when it meets the line y is equal to 4x minus 3. So the first thing we need to do is we need to first of all represent each of them so that we know where both of them meet each other. So we solve them simultaneously to get the value of x. It's so simple. So when you solve it simultaneously, you give you like quadratic equation, and you solve it, you get the value of x. So now we have two values of x. So what do we do now? The line means when you have two values of x, it means that the line, that line meets the quadratic line in two places. So then what they ask you to find the gradient of the curve where it meets the line in that particular place. So we need to find out, we need to differentiate it. So when we differentiate it, then we put 3 in the equation. So we put 3 in the equation and get 1 is 3. And when it's 1, we also solve it and get it. So that will be the gradient of the 2 points when it touches this particular thing. It's actually very nice to do. Look at this particular one. I'll say differentiate the following. It's still the same way you can do those one. What is that same way? You expand it, then go ahead and do your simple differentiation, and you get your answer straight away. Okay. Now, another thing again is that differentiation is just, you need to have a very strong knowledge of indices or algebraic manipulation. Once you know the rule, and what is that rule again? You are subtracting 1 from the power and using the power itself to multiply the function, and that's all. That is all that is there, and you get your whatever you are looking for. So the equation can now be in different algebraic format. So, but with your knowledge of indices, you can actually do it the way you want to do it. There is other forms of differentiation, which is chain rule, product rule, and quotient rule. Chain rule is when there is more than one function in a particular equation. That means when there are more than 2 power. That means there's a function that is inside a function. And how do you solve it? I've made a videos on things like that, that if you go and watch the one I actually did on the chain rule, the product rule, when there is a product, algebraic product, and you need to find it. I made a video on them. You can actually go and watch those videos. I wish I can solve more, but I want to be making my video short. So I'm going to stop here. Go and watch my videos, and I'm very sure you are going to enjoy it. Like and subscribe. Don't forget, so that I'll continue to make the video interesting for everyone. Okay, see you. Bye.